Bonjour la classe. I hope you're all having a nice weekend and welcome to another episode of Maths with Millie. Millie's here with me. Hopefully you can we see the dog? No, there's a foot. No, there's a foot. There she is. Say hello, Millie. Millie. Say hello. Hello, Millie. No. So, Millie, look this way. So she is here with us today. Very excited about doing another maths paper. Whoop, whoop. Right, okay, so we're going to finish off the paper 3 that I set you over the Easter holidays. There's already 2 videos up on it, so this is the third, hopefully the final. We'll see if we can try and wrap this up today. So starting on question 14, hopefully you can see that okay. So question 14 says, f is inversely proportional to the square of x. If you can hear any strange breathing, it's the dog. Who's really, can't quite see her, but she's right next to me. Finding a formula for f in terms of x. It says f is inversely proportional to the square of x. So even if you can't remember anything, but you can manage to write this down, that's worth a mark. So if f is inversely proportional to the square of x, so that's x squared, we can write this, f equals k over x squared. Now they've given us what I call a complete pair. If f is 0.8 when x is 5, we can substitute that in. So I've replaced f with 0.8 and x with 5. Working out, bringing the 5 squared up because that's 25. We've got 0.8 times 25 is k, so k is 20. So this gives me a general formula, f equals 20 over x squared. The next part of the question says work out the positive value of x when f is 320. So we use our equation that we worked out earlier. We replace f with 320 and work our way through. When we cancel down, we get x squared is 1 over 16. The square root of 16 is 4. So the square root of 1 over 16 is plus or minus 4, but it asks for the positive value, so x is equal to a quarter. The next question, question 15, is a parallelogram, and it's asking us to work out the area. Now I can split this parallelogram here to form 2 triangles. Now I know that that's going to be 5 as well, and that's going to be 7 because they're parallel. This angle in here is also going to be 40 degrees. And that there is just cutting our parallelogram in half. So what I've got is side angle side, so I can use the formula for the area, half AB sine C. I can't use base times height divided by 2 because when I'm using that I have to have the perpendicular height, and I haven't got the perpendicular height in this case. So substituting in what I know, just reset my calculator. So a half times 7 times 5 times sine 40, and I get 11.248, blah, blah, blah. I have to times that by 2, leaving that on my calculator so that my answer is more accurate. I get 22.49755, blah, blah, blah. Oh, it says to 1 decimal place, so I actually want to put my answer as 22.5. That's my answer there. They've already given me the units. Sometimes in questions, they give you a mark for putting down the correct units, but the units are already there. They won't say, don't forget to put your units in. They just won't tell you, and they'll expect you to put them in. If you do, they'll give you a mark. So just double check for that always. Next question. We've been doing a little bit of this recently in class. So we've got Clive wants to estimate the number of bees in a beehive. Hoping you can see that okay. There we go. Let me come back out a bit. I will get better at this. Clive wants to estimate the number of bees in the beehive. So he catches 50 bees from the beehive and he marks each with a die. He then lets the bees go. So what I've got is the actual population and the marked population. So I don't know this number just yet, but I do know that the marked population is 50. The next day, Clive catches 40 bees. So that population there is 40, and 8 of them are marked. And this is a proportionality question. The same number of bees are marked in comparison to the total population. So if I look for my multiplier there, it's 6.25. So I can go here as well, 6.25. Or I can think of it going in this direction. The marked population is 50, so I'm timesing by 5 to get 250 because the marked population was 8 and I had to times by 5 to get that population that was caught there, 40. The other way to do it is to think of it in terms of fractions. I know from working out the second time that I go and catch bees, that 8 out of 40 are marked. I know the actual population, there are 50 out of the total population marked. So it's a case of equivalent fractions, again, giving me 250. You can work at it. What have I multiplied that by? 6.25. Multiply that by 6.25. So there's 250 bees. The last bit says, write down any assumptions you have made. No bees die, no bees are born, the dye does not rub off, all the bees don't suddenly to go and live somewhere else. So basically that all works on the population is constant, there's a constant population. Pretty much all the same for those types of questions. Question 17. A new shopping centre is opened and 500 new jobs are created. After 2 years, the number of jobs has increased to 700. Assuming the number of jobs in the shopping centre increases exponentially, just done that last week in class, work out how many jobs there will be in 5 years after the shopping centre first opened. Now looking at my increase, there's a couple of ways to do this. So there is always a couple of ways to do this, isn't there? So looking at my multiplier here from 500 to 700, dividing one by the other, I get 1.4. Oops. There we go. Yeah, that looks like 1.4, doesn't it? That is what this, if I multiply this and this by the same number, I get 1.4. So I've got to try and figure out what year 5 is. So what I've actually done is 500 r squared equals 700. So I know that r squared is equal to 700 divided by 500, which is 1.4. If I square root that, I get 1.1832, and so it goes. So this here is my multiplier. I want to know what it is in year 5. So I'm going to take my original population of 500 and times it by 1.18 to the power, well, let's work this out. Year 1, I've times by r there. To get to year 2, I times by r again. So to get to year 3 and year 4, I'm again multiplying by r, multiplying by r, multiplying by r. So to move from the beginning, I've multiplied by r 1, 2, 3, 4, 5 times. Remember, it's not always the year that you're in that you're doing the multiplier at, because sometimes questions start with, in year 1, this is the number. So just be really careful and just double check that you're multiplying by the correct power or using the correct power. I'm leaving that value there on my calculator, putting it to the power 5 because I want to be as accurate as possible, and then timesing that by 500. On my calculator, I get 1159.55, etc. I can't have 0.55 of a job, so I round up 1160. In the mark scheme, they accept 1160 or 1159. So some algebraic fractions. Write as a single fraction in the simplest form. So the first thing that we need here is a common denominator. So multiplying those two together, I get the common denominator of x minus 4, x plus 3. I've multiplied this fraction here. I've multiplied the bottom by x plus 3. So I'm going to do exactly the same to the top to create an equivalent fraction. This one I've multiplied by x minus 4, so I'm going to do exactly the same to the top to get another equivalent fraction. So multiplying out the top of my brackets, I've got 2x plus 6 minus x. The minus times the minus there gives me a positive 4 all over x minus 4, x plus 3. Tidying that up gives me x plus 2, sorry, x plus 10, 6 plus 4 is 10, over x minus 4 times x plus 3. So my final answer, x plus 10 over x minus 4, x plus 3. Sorry, another typo there if you like. So 6 plus 4 is 10, 2x minus x gives me the x. Denominator stays the same, make sure you copy it correctly, and there's your final answer there. Right, question number 19, almost on our last question here, but what I'm going to do, because it's been going on for 12 minutes, I'm going to stop there and I'll finish those ones up later on the next video. Thank you.